Hello friends, today we are going to discuss another topic of plasma physics, that is upper hybrid oscillation. So in the last video we have already discussed about electron plasma wave. Not in the last video, in lecture 15, I think not 15, 16, yes, in lecture 16 we have discussed electron plasma wave, and in that case we have considered there was no magnetic field was not applied there, and we have obtained a dispersion relation that omega square is equal to omega p square plus 3 by 2 k square Vth square, where Vth represents thermal velocity. So here you see, in this case this omega p, this was plasma frequency, and here now in this case we are going to observe the upper hybrid oscillation. That means the oscillation of electrons in presence of magnetic field. If the magnetic field is applied in the direction perpendicular to the plasma wave, then we will study the behavior of the oscillation. So in that case, for simplicity, we are going to ignore this thermal motion here, and we will due to application of this magnetic field, we will have a cyclotron frequency omega c. So now let me show you. So in this case we are going to assume that ions are stationary. So we are going to assume that, let us assume ions are stationary. As they are massive. And also we are going to assume that there is no thermal motion. So temperature Te, this must be equal to 0. Electron temperature must considered to be 0, and we are going to assume that B field is applied in z direction. So in this direction, z direction, B field is applied, and direction of the wave, propagation of wave, is along x direction. The equation of motion of plasma fluid. So equation of motion, that is given by Mn. These symbols have the usual meaning, okay, as we have assumed in previous videos, okay. Del V by del T plus VE dot del into VE is equal to minus En E plus VE cross B, where B represents magnetic field, which is applied in z direction. This is suppose equation number 1. Now here you see, if we apply linearization condition, applying linearization, so, and we have to use these conditions here, that n is equal to n naught plus n1, VE is equal to V naught plus V1, VE1, you can use simply V1 as well, so that's not a big deal. E is equal to E naught plus E1. Then at equilibrium, so there will be no change in number of particles n naught, grade n naught must be equal to 0, VE naught, and also E naught is also equal to 0, and hence we can say del n naught by del T is equal to del V naught by del T is equal to del E naught by del T are also equal to 0. So, if we apply those conditions and after linearizing, equation number 1 implies that yes, equation number 1 implies that here m n1. So, as we have considered those here you see grade n naught, V naught, E naught, these are equal to 0, and these terms are also equal to 0. If we apply those conditions in equation number 1, so we will get mn1 del ve1 by del t is equal to minus n1 e1 plus ve1 cross b naught. B naught is the magnetic field applied applied in the z direction, that means B field. So B naught represents the B field applied in z direction. So hope you have understood this. Now here you can see this n1 this n1 and this n1 cancels each other from the both side, and this equation implies m del ve1 by del t is equal to minus E capital E1 plus ve1 cross B naught. This is suppose equation number 2. Now let me scroll down the page. So if we apply the same method in equation of continuity, again linearizing equation of continuity, as we have already discussed how to linearize those equations in previous videos, so that's why I am not explaining in details. Okay, so linearization let me write here. So linearizing equation of continuity, we have, so if we linearize the equation of continuity, then we are going to have del n1 by del t plus n naught del dot ve1 is equal to 0. That's suppose equation number 3. Now Poisson's equation, applying the same method, here we can have del dot E1 is equal to minus 4 pi En1. So this is equation number 4. Now, so as the wave is propagating along x-axis, okay, so here we can write as the wave is propagating along x-axis. So here you see, and the wave is longitudinal in this case. So the wave constant k and the electric field E1 are along x-axis. So we are going to have the y and z component of these two, ky, kz, and ey, ez, these are all 0, as these two are along x-axis. So their y and z components must be equal to 0. So hope you have understood this. So let me write here x-axis. Okay, so suppose k is equal to k x cap and e is equal to e x cap. Now let us find VE1 cross B0. So that's going to be given by, so let me scroll up. So here this is I, j and k. Let me find a cross product of these two. So three components of velocity Vx, Vy, Vz, and magnetic field is being applied along z direction only. So first two components must be 0, then last one is B0, which is applied along z direction. So if you evaluate this, then you will have Vy dot B0 into j, sorry not j, I cap minus Vx B0 j cap plus 0 into k, that is 0 simply. So from equation number 2, so from this equation, sorry let me scroll up the page. From this equation, if you replace the del t by this minus I omega and del operator by ik, then what will happen? So here we can have, from equation 2, this will give us minus mi omega Vx is equal to minus e capital E1 minus small e again Vy B0. So here you see, if you go to equation number 2, so in this case, so what we have done here, if we find the three components, if we take the three components x, y and z component from this equation number 2, we will get three equations. So one is this one, this is for the x component. So that's why we have here we have used, instead of VE1 we have used Vx here, and x component of V cross B0 is here this one Vy B0 I. So Vy B0 here, and here we have replaced the del t by omega. This one is omega, and so, and from this from the same equation we will have other two equations for other two components, y and z components. We will have minus mi omega Vy for y component, e capital E1 minus, so y component of V cross B is this Vx B0. So Vx B0, so it's gonna be positive here, as this is negative, positive. But here one thing you have to remember, that we have only applied the magnet we know that this electric field is along z axis, sorry x axis only. So here this term will be vanished. Okay, so we will have only this term. So let me write it here. Okay, then for the z component we are going to have minus mi omega Vz, that's going to be equal to 0. As you can see from this cross product, we have got the z component 0 into k, that's equal to 0. So here this term will be 0, so that's why here we will get 0. So we have three equations, and those are respectively equation number 5, 6 and equation number 7. Okay, so we have these three equations, and from equation number 6, now let me take equation number 6. From equation number 6, so what we're going to have in this case, let me find Vy from here. If you find Vy, then you will have from this equation, if you simplify, find Vy, so what you are going to have, E Vx b naught by minus m I omega, and using it in equation 5, using it in equation 5, in equation number 5, so what we're going to have in this case, we are going to have minus mi omega Vx is equal to minus E capital E1 minus E, again within bracket, small e Vx b naught by minus mi omega to b naught. So here you can multiply all the terms by minus 1, then all the terms become positive, and here you see you can simplify this term as, so here E is going to be E square, so you can simplify this one as m by omega as E b naught by m Vx, and here you can write square. Okay, so here you see, so that means how we have obtained this. So let me explain it here. Now you see, from this term, if you write m by omega, this omega is written outside. Okay, this is omega, m by omega, then here this is E square, then b naught by, so b naught, and not only b naught, there must be b naught square, so b naught square, so minus, so minus is taken outside here. So instead of taking the minus, what we can do here, we will multiply this numerator and denominator both by I, then this term will be positive, and here we will get only m, then Vx, so Vx, this is going to be m square, then after cancelling this one by this, we will get m here in this case. Here you see, so now what we have done here, here you see, now this term within bracket, here, this is nothing but cyclotron frequency omega c. So we have already discussed in earlier classes. So we can replace this by omega c, and doing so, this equation is found to be mi omega, sorry, this is Vx. Okay, so here it is Vx is equal to E capital E1 plus omega c square mi Vx by omega, where we can write omega c square is equal to E square b naught square by m square. So hope you have understood this. Now if you divide both sides by this left hand side, if you divide both sides by this left hand side, mi omega Vx, then what will happen, what you will get, so here this is I, here you will get 1, and you will get on the right hand side E capital E1 by m I omega m into I omega Vx plus omega c square m I Vx by m I omega square Vx. Okay, then so what we can do here, we can cancel something. This m cancel, I cancel, so then this will imply, so what will happen, okay, let me scroll up the page, sorry, scroll down the page, and also one more thing will be cancelled, that is Vx and Vx. Okay, so here we have got only omega square, omega c square by omega square, so this term we have got, and if you shift this term on the to the left hand side, then what you will get, this will imply that e omega capital E1 m I omega Vx is equal to 1 minus omega c square by omega square, and this is gonna imply Vx is equal to e capital E1 by I m omega by 1 minus omega c square by omega square. So this is equation number 8. Suppose this is equation number. Now from equation number 3, now if you see the equation number 3, here you see this one, the equation number equation of continuity. So if we take this equation, if we replace the del t by if you replace del t by minus I omega and del by ik, so let me write here, so let me write here, replacing my del by del t by minus I omega and del by ik, then equation 3 implies, this equation number 3 implies, what was the equation? So here you can say this is the equation, and this will imply minus I omega n1 plus n naught I k Vx is equal to 0. So if we replace this V of x for the x component, so if Vx is replaced by this value from equation number 1, this Vx is replaced in this equation, then what will it happen? Then this will imply, before replacing this Vx, let me simplify this equation. So let me simplify this equation. So from here we can find n1 will be given by n naught k V of x by omega. Okay, this is suppose equation number 9. So now let us do one thing, let us use these two, equation number 8 and equation number 9, in equation number 4. Let me use these two equations in equation number 4. So here is the equation number 4, this is equation number 4, Poisson's equation. So here in Poisson's equation we are going to use these two equations. So replacing this, here you see replacing del t by minus I omega and ik, del by ik, then this equation number 4 becomes, this equation becomes ik E1 is equal to minus 4 pi E n1. So now let us use equation number 8 and equation number 9 in this equation. So if you use the, so how to use this? So here we are going to replace the n1 by this value, and also we are going to replace here and this Vx, here this Vx will be replaced by that value, and the resultant value will be used in this equation. Okay, so doing so, what we are going to have, I k E1 minus 4 pi E n naught k by omega, then the Vx, this Vx is now replaced by this term, this right hand side in equation number 8 of equation number 8, and that's E capital E1 by I m omega by 1 minus omega c square by omega square. So finally we have got, so here what we have done, using equation number 8 and equation number 9. Okay, so that's what we have done. So here what we can do, here E1 will be cancelled, then so, and also k will be cancelled by this k. Then is there anything? I don't think so. So then in that case, what we can have, so here it is I, when you will simplify, this I will multiply by this I, then gives -1, so this minus will be positive. So, and that implies 1 minus omega c square by omega, that's going to be equal to 4 pi E square n naught by m omega square. So now let me scroll down the page. Here you see, so this is going to be equal to omega c square by omega, and this term, here you see, this term is nothing but it is equal to, this is equal to omega p square, cyclotron frequency. So omega p is cyclotron frequency, and this is equal to omega p square. Okay, so we can replace this one by omega p square, and so if you multiply here both side, so what we gonna do here, let me say one thing. Okay, sorry, let me do one more thing here. This is not equal. Now let us multiply the both sides by omega square, then what will happen, it implies omega square minus omega c square and 4 pi E square n naught by m only, and this term, you see, this term is nothing but omega p square. So omega p is plasma frequency, so we have already discussed in previous videos. Okay, so here you see, when we have discussed plasma oscillation, so in that lecture we have got this one. Okay, so here omega square will be omega p square plus omega c square, and this is the dispersion relation, required relation here we have got. And here you see, this frequency is due to the electric field generated due to the oscillation of ions, and this frequency due to application of the magnetic field in the perpendicular direction of the wave, electron wave. So hope you have understood this. So this is the dispersion relation. And here this is equal to, so let me write one more thing here, this is equivalent to the upper hybrid frequency. So hope you have understood. So this is the upper hybrid frequency. So thank you for watching. If you like my video, then share with your friends, and if you are new to my channel, subscribe the channel. Thank you for watching.